Welcome to Module 20 of our course. This module will focus on automated web application security testing. The three approaches used in the automated software security testing are white box, gray box, and black box testing. White box testing is a technique which necessitates the full knowledge of an application's code and can utilize static code analysis tools. By contrast, black box testers are unaware of the source code and treat the application like a literal black box, where the user parameters are the input and the generated page is the analyzed output. Gray box testing combines the two methods. Testers may know the source code, but don't delve deep enough into analyzing it. The testers could also be unaware of the code but have other information on internal functioning of the application. If that's the case, a gray box tester could come up with better attack scenarios while utilizing the tools and techniques of black box testing. This module will talk about black and white box testing. Since gray box testing is a subclass of sorts of black box testing and is not directly supported by specific tools, it won't be covered here. You can see here the Havij Advanced SQL Injection Tool application, which can be used for black box testing. It serves to detect and exploit SQL injection vulnerabilities. Let's enter as the target the URL of an example we talked about in the module on SQL injection attacks. The entered URL is correct and displays a normal website. As you can see, the tool first searches for a keyword which is later used to specify if a query has been successful. Next, it identifies the SQL injection attack as an attack on the unprotected numerical variable. The tool has detected that the server uses MySQL 5 database or newer versions. The number of columns used by the query has also been found, as well as the column which will be displayed on the website. The name of the used database has also been discovered. Now we're completely sure that the tested page is vulnerable to SQL injection attacks. Let's use other features of this tool to retrieve additional information on the database. As you can see, the current user has been displayed, as well as database version, current database, host name, installation directory, and passwords for the root and test users. The passwords are hashed, but a potential attacker could take a shot at cracking them. You can also see that the current user has access to the test, MySQL, and information schema databases. Using the tables function, you can load databases accessed by the user and then load a set of tables used by the database. You can also load table columns and the data stored in the tables. As you can see, the tool has automatically detected an SQL injection vulnerability and exploited it without knowing the source code. There are similar black box testing tools used to search for the XSS, path traversal, and PHP injection vulnerabilities. Remember that black box testing tools utilize existent attack scenarios and may not be able to cope with more complicated cases. In this case, the manual analysis of a web application behavior and preparing unique attack scenarios, the methods used in gray box testing, might be helpful. If you have access to a website's code, you could also utilize white box testing tools. You can see here the RIPS framework, a PHP scanner used for testing applications written in PHP. Several files used in previous attacks have been placed in the scripts directory. Each containing a different type of vulnerability, such as the SQL injection, XSS, and PHP injection vulnerabilities. Let's now check the results of analyzing the code in this framework. Scanning has started. As you can see, 2 SQL injection vulnerabilities and 1 file inclusion vulnerability have been found. A report has also been generated which contains the number of scanned files and statistics on including subpages. In this case, the scripts are autonomous, but if they included other files, the framework would also scan them. You can see here the number of potential sinks, which are the actual locations where a vulnerability is exploited. These could, for example, be the functions which communicate with databases, or which include files. Functions declared is self-explanatory and indicates the number of functions declared in analyzed files. Unique sources indicates the number of sources, user input parameters. Sensitive sinks specifies the number of vulnerable sinks that are reached by unfiltered user input. The SQL injection vulnerability is the first detected hole. You can see here lines of the vulnerable code, the used parameters. Once you click on the question mark, information on the vulnerability class and the detected case will be displayed. The source here is the get variable, which contains the parameters. The sink is the MySQL query function, which executes SQL queries. If unfiltered source data reaches the sink, this potentially could trigger a vulnerability exploitation. The vulnerability here is the SQL injection flaw. The shown information also includes a description of a given vulnerability case, examples of vulnerable code and exploitation scenarios, techniques for removing the flaw, and other related topics. As you can see, this tool could be helpful in the quick and efficient detection of potential code vulnerabilities. Naturally, the framework could also return so-called false positives, or script lines which are not actually vulnerable in their specific usage. This could happen because a detailed analysis of each case might not be feasible, or because the analysis depends on too many external factors or is simply too complicated. Nonetheless, all information on potentially dangerous locations is valuable. You can view here a report on the second occurrence of an SQL injection vulnerability in the guestbook PHP file along with the similar information. Finally, you can see here an instance of PHP injection vulnerability. You can also find out more on this specific occurrence and the vulnerability class in general. To scan the application for XSS vulnerabilities, switch the framework to a different mode. As you can see, the XSS flaw has been detected. In this case, an SQL injection vulnerability could lead to the injection of HTML code. If we switch the source type to data coming from databases or files, the tool will also detect stored XSS vulnerabilities, such as our guestbook script. As you can see, the tools used for black box testing and white box testing might be really helpful. Remember though, that auditing security needs the experience and brainpower of actual humans, so don't fully rely on software. Rather, use it as additional and valuable help. That's all in Module 20, and it's also the end of this course. I hope that the resources and advice we've given you have proved useful and very interesting. Thanks for your attention. Please feel free to check other training courses which you can find on our website. See you!